All right, so I'm going to kind of toggle between screens here. So to go through ionic equations, what I do is I put the first two here, and I'm keeping the decompositions. I know it's a little sloppy, and the strong acids as reference. I also have the flow chart here. You should also have your polyatomic ion list and your periodic table. All right, so the first thing you want to do, so this is the first one, is you have to write the balanced equation. A good idea in doing that is write the ions first. I'm not going to go through the balancing part for everyone, but I'll do it at least for the first one or two. So nickel 2 is nickel, and it's a 2+. And we know it's a 2+ because it says so right there. Nitrate, if it ends in 8, it's a polyatomic ion. Potassium is K, and it's a group 1 metal, so it's +1. Phosphate is also a polyatomic ion, PO4. So these you look up. When you have them memorized, you look up between your ears, and until then, you look it up on the sheet of paper. I will give you the polyatomic ion list for exam 3, but not for exam 4 or the final. The products, may as well do the ions for the products while you have them here. It's going to be nickel, but nickel will be with the phosphate because the positive can only go with the other negative. If you do this step here where you write down the ions, there's a lot of very common mistakes that if you do this, it's much harder to make those mistakes. So now we can put these together. So this will be NiNO3 2 because we need 2 nitrates. This will be K3 PO4. That's a P. This will be Ni3 PO4 2 and KNO3. So in the interest of time, I'm not going to go through or review how I got these subscripts, but you can review those videos, or you can certainly come by during office hours. All right, now to balance this, I just make a list of I do it element by element, and I always do oxygen last. You can do actually the polyatomic ions as one entity as long as they stay together. And then just in the interest of being organized, whatever order you go in on the left, go in that same order on the right. So I'm not going to go through the balancing steps for each one, but for the first one I will. So we just count. Nickel, there's 1. Nitrogen, there are 2. Potassium, there are 3. Phosphorus, there is 1. Oxygen, there are 6, and 4 is 10. On the right-hand side, there's 3 nickels. There's 1 nitrogen. There's 1 potassium. There's 2 phosphorus. And there's 8 and 3, 11 oxygens. All right, so now what we do is we need to fix, just go one at a time. To fix things, you use coefficients. Let me just make this a little bit wider. All right, so I'm going to put a 3 in front of the nickel nitrate here. Now, when I put that 3 there, what it does is it makes the nickel a 3. But anytime you change a coefficient, you need to recount. So I have 3 nickels, but I now have 2 times 3 is 6 nitrogens. The potassium didn't change. The phosphorus didn't change. The oxygen, though, is 6 times 3 is 18, and 4 is 22. But the nickel is fixed. Now we'll go to the nitrogen. There's 6 nitrogens on the left. There's only 1 on the right. So I can put a 6 in front of the KNO3. That doesn't change the nickel. The nitrogen is 6, which is what we were shooting for. The potassium is also a 6 now. The phosphorus did not change. The oxygen is 8 and 18, right? 6 times 3 is 18, and 8 is 26. But the nickel and the nitrogen are now balanced. Now we'll go to the potassium. I have 6 on the right. I only have 3 on the left, so I'm going to put a 2 in front of the K3PO4. And now I recount. The nickel didn't change. The nitrogen didn't change. The potassium is now a 6. The phosphorus is now a 2. And the oxygen is 18 and 8. 2 times 4 is 26. All right, but the nickel and the nitrogen and the potassium. And you see how the phosphorus and the oxygen fell out for us. All right, so that's the balanced equation. I'm going to erase this bookkeeping. And usually when you're balancing an equation, it should kind of be like that. If you start going in circles, 99 times out of 100, if a student has trouble balancing an equation, they have a formula wrong. All right, so the next step here is to go through this flow chart. So we look at each of the substances and we classify them as ionic, covalent, or acid. All right, so all of these actually are ionic. And we know they're ionic because they contain ions. They contain metals. They also contain polyatomic ions. So in this case, they're all ionic. All right, so if they're ionic, we don't worry about this now because we don't have any, but we're going to use the solubility rules to determine if they're soluble or not. So just to move this over so I can see what I'm doing here. So these are the solubility rules. These will be attached to your exam. So for the nickel nitrate, we look at, and as soon as you have a rule that says soluble, you're done. Nitrates are soluble. So that means this one is soluble. Let's do that. I'm just going to do them one at a time. Potassium phosphate. Okay, the first rule doesn't apply, but potassium is an alkali metal. It's a group 1 metal. All compounds containing group 1 metals are soluble. Nickel phosphate, right? Not a nitrate. Rule 2 doesn't apply. Rule 3 doesn't apply. Rule 4 doesn't apply. Rule 5, phosphates. Phosphates are soluble, insoluble, excuse me. So this is insoluble. And then the last one, now you've noticed, by the way, potassium phosphate, I have a phosphate here, but this is soluble. That's because rule 2, if you have a rule that says it's soluble, you're done. All right, potassium nitrate, we have 2 rules that say it's soluble. It's a nitrate and it's a potassium. All right, now, once we've determined the solubility for ionic compounds, we're going to break soluble ones into ions and leave insolubles unchanged. So I'm going to move this back over now. So the soluble, we're going to break into ions. So since we already have the ions up here, it's pretty easy. So we're going to, it's 3, and somebody in one of the breakout rooms asked me, do I distribute it through? And yes, we do. So there's 3 nickels. There are 6 nitrates, 3 times 2. There are 6 potassiums. See, they're just Ks, they're not K3s. 2 times 3, 6 K pluses. 2 PO4s. So the PO4 stays together. The insoluble, whoops, I left off at 3 there. The insoluble we leave alone because that's what it says to do. And then the soluble we break into ions, 6 K pluses and 6 NO3s. Squeezed it in. All right, then the last step, once we've written this is actually what's happening, and in water, this is what it looks like. The last step is we do what's called, we cancel out what are called spectator ions, which are things that are the same on both sides. So see, the nickel is uncombined here, but it's combined on the right. The nitrate is uncombined, thus we're going to cancel it out. The potassium, same thing. The phosphate is changed. And so now we're just going to write the net ionic equation, which is really just cleaning it up. 3 nickels, 2 phosphates makes nickel phosphate, nickel 2 phosphate. All right, so there's your process. Let me go to the next one, but if there's questions, now's a good time. I'm going to just kind of go back and forth between these 2 panels. Ammonium is NH4+, so that's one of your polyatomic ions. Chloride is Cl-, it's a non-metal ion. So you see how you have to be able to write ions? Calcium ion, acetate, polyatomic ion. The products will be when we switch them. I always write the ions first before I put them together. NH4+, what a mess. C2H3O2-, and then Ca2+ with the Cl-. Now we can put them together. NH4Cl, that's a 4. Ca, C2H3O2, 2, arrow, NH4, C2H3O2, and then CaCl2. All right, to balance it, the ends are balanced. The Cl's, though, we have 2 here. So we're going to have to put a 2 in front of the ammonium chloride. That means we're going to have to put a 2 in front of the ammonium acetate to balance the nitrogens. If the nitrogens are balanced, the chlorines are balanced. I'm not going to do all that writing things down. Calcium is balanced. The carbons, yeah, this whole mess is balanced. So this is actually balanced as written. Okay, now I'm going to here. Okay, all of these are also ionic. They all contain polyatomic ions, so these are all ionic. So now what we need to do is determine the solubility. So that means I'm going to look at my solubility rules. So nitrates and acetates, no, I'm just going to go look at ammonium chloride. That is a ammonium compound. Ammonium compounds are soluble. All right. The acetate, right, is soluble, except for it's not silver acetate. This has 2 rules. It says it's soluble because it's an ammonium and it's an acetate. And then the calcium chloride, rule 3, halides, which are the halogens, are soluble except with silver, lead, and mercury, but that's calcium. So this is soluble ionic. Scooch this over just a little bit. All right, so now if you remember, what we do next is we take for ionic compounds, whoops, if they're soluble, we break them into ions. Insoluble, we leave alone. So we're going to break these into ions. 2 NH4 pluses, 2 Cl's, Ca2 plus, 2 acetates. Okay, I'm going to write the products here. 2 NH4s, that's soluble. 2 acetates. The calcium. And 2 chlorides. Leave myself quite enough space. All right. And now we can start canceling. See, in this case, everything cancels. So what that means is there's no reaction. NR for no reaction. So that's the thing, that part of the reason of doing ionic equations, other than there's a lot of stuff you need to be able to do from an instructional perspective, is I can write this equation, but actually this doesn't react. All right, let me go to the next 2. Whoops. All right, the next one was, whoops, where'd it go?
Oh, wait, Professor, I had a real quick question.
Yeah.
So do you think you could go over again how you got the ions, like the step immediately after you went over solubility, how you know which ones to break up? And it looks like you split it into 4 different parts and then 4 different parts. I was just wondering.
Yeah, so what I did, yeah, I can tell you, is I kept, see how this ion here? I kept the ion together, right? I didn't break the N and the H. So since I had the ions listed, ammonium, chloride, calcium, acetate. I don't take the elements in the ions out. I leave the ion together. So NH4, I left together. Cl, I left together. Ca, right? The acetate, all the C2H3 and the O2 stay together.
Oh, okay.
Yeah. Does that answer your question?
Yeah, that does. Thank you.
And then this is lead 2 nitrate. All right. So again, if it's acids, it's H plus. Hydroiodic means it's I. Lead 2 is Pb2 plus. Nitrate we already did, NO3 minus. Products will be when they switch, H plus with the NO3, Pb with the I. I do this a little bit more quickly. So then we're going to have HI, Pb, NO3, 2, HNO3, and PbI2. And to balance it, we're going to need a 2 here and a 2 in front of the nitric acid. So I'm doing that a little bit more quickly in the interest of time, but I went through the steps on balancing. Okay, and you can certainly take your time to do that as necessary. Now, classification. HI is an acid, so for the acids, we need to know if it's strong or weak, right? Determine if it's strong or weak. I even have the 6 strong acids listed in this box. So HI is a strong acid. So I'm going to write SA for strong acid. This is ionic. All right, so ionic compounds, we look at the solubility. All nitrates are soluble. So this is soluble. This is an acid, and nitric acid is a strong acid. So that's SA again. And then this is ionic because it contains a metal. So then we need to look at that. Compounds of the halides, chlorine, bromine, and iodine, so there's no nitrates. I'm just going to go through the rules, are soluble except, whoops, lead. So this is actually an insoluble compound. Lead iodide actually is bright yellow. All right, so now what we do, the strong acids, we're going to break it. If you look at the flow chart, the strong acids, we break into ions, and the soluble ionics, we break into ions. The insoluble, we leave unchanged. So the strong acid, so this is going to be 2H plus. This is your question about the ions again. If you do this step here to list them, it's obvious how things break up. 2I minus. This breaks up, Pb 2 plus, 2 NO3s. The strong acid we break into ions, 2H plus, 2 NO3s. And then the lead iodide we leave alone. Insoluble we leave alone. And then we start canceling. You'll see the H's cancel. The iodines do not. The leads do not. The nitrates cancel. And so we have 2I minus plus Pb 2 plus goes to PbI2. I see a question. Yes, I can slow down a bit. All right, let me erase. I need to close that. Okay, the next one is potassium carbonate and acetic acid. Let me write that down. All right, so potassium is K. Carbonate, polyatomic ion. Okay, all acids are H plus. So acetic, remember the ic, ate, ite, us, acetic is from acetate. The products will be when we switch them. So the K plus will go with the acetate. And the H plus will go with the carbonate. Putting them together, K2CO3. Geez, my handwriting is going from bad to worse. We're going to write this, we always write the H first in acids. So H, C2, H3O2. We need K, this is 1-to-1. So K, C2, H3O2. And then H2CO3. Now, one thing you want to look out for is look in your products and see if any of the compounds are these decompositions. And if they are, you need to decompose it. And there's a lot more than these four. These are the four that in Chem 152 we want you to memorize because they're very common. So you see how the carbonic acid, the H2CO3 decomposes? I have it written up here. So I'm going to cross it out and write H2O plus CO2 because that's what it decomposes into. To balance this, we're going to need a 2 in front of the K, and we're going to need a 2 here. And you can verify for yourself that that's balanced. All right, now, each of these, I'm going to do this a little bit, well, not more quickly, but so we look at ionic, covalent, or acid. So this is ionic because it has a metal. This is an acid. This is ionic. These two are covalent. All right, so for the ionic, we need to do the two ionics, we need to look if they're soluble or not. So I'll just kind of do them both at the same time. They both contain potassium, which is an alkali metal. I didn't list it here, but it says etc. So these are both soluble. The acid is a weak acid. Where'd it go? Here. It's not a strong acid. That means it's weak. There's only 6 strong acids. So I'm going to write W. And then if you look at covalent, we don't need to make any decisions. So then what we do for soluble ionics, going back to the flow chart, soluble ionics, we break into ions. Weak acids, we leave alone. Okay, so we're going to break this into ions. So again, it's 2 Ks. The weak acid we leave alone. Only strong acids get broken into ions. 2HC2, 3O2. There. This we break into ions. 2K plus 2 acetates. Covalent compounds we leave unchanged. So when you're going through homework 9, which is long, also experiment 8 has a really nice treatment of this stuff in the background. It's good to have that flow chart handy while you're doing this. All right, so now the last step is we're going to cancel out the spectators. The potassium is a spectator. The carbonate is not. The acid, that's it. The only spectator is the potassium. So our net ionic equation is carbonate ion, 2 acetic acids. Acetic acid is the acid in vinegar, by the way. Then we will get 2 acetate ions. And then we'll get water and carbon dioxide. So you'd see bubbling if you did this reaction. All right, do the last one here. Then I'll turn off the recording and I'll leave it for questions. And of course, like always, I do have to close the Zoom session before lab, but then I'll reopen it right away. All right, the last one was ammonium sulfate and barium hydroxide. Whoops, where'd it go? Here it is, the whiteboard. All right, so ammonium is NH4 plus sulfate. And I organize it this way, you know, or kind of vertically. You can organize it. It doesn't matter if you organize it the way I do or you organize it your own way, but it matters. You really should be organized. Whatever organizational scheme you want to use is kind of up to you. All right, then we put these together. It's going to be NH4 2SO4 BaOH2 NH4OH and BaSO4. Again, we have a decomposition here. You always just ask yourself, is one of them listed? So I'm going to break this up into NH3 and H2O. To balance it, we're going to need a 2 here and a 2 in front of the water. All right, then this is ionic. So I just click on here real quickly. Ionic, covalent, or acid. So this is ionic. This is ionic, barium hydroxide. These two are covalent. And this is ionic. So I have 3 ionic compounds. That means I have to look at the solubility rules for those 3. Where'd that go? Here. So let's see, what's the first one again? Ammonium sulfate. Whoops. See, it's hard to do this. Come on. There it is. All ammonium compounds are soluble. All right. So this is soluble. All right. Barium hydroxide. Nope. Nope. Number 4 is hydroxides are insoluble except barium hydroxide. So that's an exception. So this is soluble. And then barium sulfate is the last one that we have to look up. Sulfates are soluble except with silver, lead, mercury, and barium. So this is insoluble. All right, so soluble ionics, we break into ions, remember? Barium hydroxide will break into ions. The covalent compounds will leave alone. And the insoluble will leave alone. And now we cancel out the spectators, but there are no spectators in this case. So that means that this is the net ionic equation. All right, I went over by 1 minute. I apologize for that. I'm going to turn off the recording. And then I can answer questions. And then, of course, you know how we do things. So let me stop the recording, and I'll post this later today.